Welcome to the DIY Honda Garage channel. DTC P2185 refers to a specific error concerning the Engine Coolant Temperature ECT Sensor 2, indicating that there is high voltage in its circuit. This Diagnostic Trouble Code DTC is critical because it signals that the ECT sensor, which is responsible for measuring the temperature of the engine coolant, is not functioning correctly. The ECT sensor plays a pivotal role in the vehicle's performance, as it sends temperature data to the Powertrain Control Module, PCM, to manage fuel injection and ignition timing effectively. In the Honda HR-V model years from 2016 to 2022, the ECT Sensor 2 is usually located in a spot that allows it to measure the coolant temperature accurately. Because this sensor directly impacts engine operations, it is essential to diagnose and resolve any issues related to this error promptly. The Diagnostic Trouble Code P2185 indicates a high voltage condition in the ECT Sensor 2 circuit. This is an essential component in monitoring the temperature of the engine coolant. The ECT sensor has a vital role. It ensures the engine runs at optimal temperatures by providing accurate feedback to the PCM. High voltage readings can prevent the PCM from accurately ascertaining the coolant temperature, affecting engine performance. The ECT Sensor 2 is commonly positioned near the engine block or coolant outlet for precise measurement. A faulty reading can lead to incorrect fuel mixture and timing adjustments, causing potential engine performance issues. There are several possible causes for the DTC P2185. Firstly, you could have high voltage signals originating from the ECT sensor circuit. This situation can stem from a short circuit or wire damage that allows excessive voltage to flow. Secondly, poor connections, either at the ECT sensor or the PCM, could lead to intermittent issues that trigger this DTC. It's crucial to inspect connectors and terminals for any signs of corrosion or loose connections. Lastly, a faulty ECT sensor itself can lead to inaccurate readings that trigger this high voltage error. Each of these scenarios must be evaluated in the troubleshooting process to ensure accurate repairs. The symptoms associated with DTC P2185 can significantly affect vehicle performance. Commonly, you will notice engine performance issues, including rough idling or irregular acceleration. This is because the incorrect coolant temperature readings lead to improper fuel-air mixture adjustments. Another symptom could be increased fuel consumption, as the engine may run rich or lean due to inaccurate temperature data. In many cases, the check engine light will illuminate on the dashboard, serving as a warning to the driver that a problem exists within the engine coolant temperature monitoring system. Timely diagnosis and repair are essential to prevent further complications. In the first troubleshooting step, you'll need to turn the vehicle to the on mode without starting it. Following this, check the ECT Sensor 2 parameters using the Honda Diagnostic System, HDS. You're specifically looking for the voltage levels, particularly ensuring they exceed 4.92 volts. If the voltage read from the sensor aligns with these threshold values, then the issue is confirmed, indicating that something is indeed wrong. If it doesn't match, it suggests an intermittent failure may be occurring. In such cases, check for poor connections or loose terminals at both the ECT Sensor 2 and the Powertrain Control Module, PCM. If freeze data indicates a previous failure, attempt to replicate those conditions for further diagnostics. The second step requires you to turn the vehicle to the off or lock mode. Carefully disconnect the ECT Sensor 2 2-pin connector to proceed with testing. Using a jumper wire, connect terminals A and B of this connector, where terminal A corresponds to the first terminal of the 2P connector, and terminal B corresponds to the second terminal. After establishing this connection, turn the ignition back to the on mode again without starting the engine. At this stage, measure the voltage again using the HDS. You are particularly checking if the voltage exceeds 4.92 volts. If it does, proceed to the next step. If the voltage does not meet the threshold, the ECT sensor 2 itself needs to be replaced. In this step, revert the vehicle to the off or lock mode and carefully remove the jumper wire you used previously. Switch the ignition to on mode again without starting the vehicle. Then, you will check the voltage between the first terminal of the ECT sensor 2 connector and the body ground. This is crucial, as you are confirming whether there is about 5.0 volts present. This measurement helps you ascertain the integrity of the TW2 sensor line, which provides vital data to the PCM. If the voltage is about 5.0 volts, this line is likely functional, and you can proceed. If not, follow the next troubleshooting step to investigate further. For this troubleshooting step, once again turn the vehicle to the off or lock mode. You'll need to jump the SCS line using the HDS framework, which facilitates diagnostics by shorting the SCS line. Then, disconnect connector A from the PCM, which is a 51-pin connector. At this point, check for continuity between the two test points. Test point 1 at pin 47 on the PCM connector A, and test point 2 at pin 2 on the ECT sensor 2 connector. You are verifying whether continuity exists between these points. If continuity is confirmed, the SG5 wire appears to be functioning correctly. If the DTC P2185 is resolved after this check, you may consider updating the PCM software. If not, further diagnosis of the PCM might be necessary. In the final step, revert back to the off or lock mode. Similar to the previous step, jump the SCS line within the HDS setup once again. After this, you'll disconnect the PCM connector A, ensuring you have access to contact 46. Next, check for continuity between this test point on the PCM and the first terminal of the ECT sensor 2 connector. This check will confirm the integrity of the TW2 sensor line. If there is continuity, you may proceed to update the PCM software or replace it with a known good unit for troubleshooting. If this resolves the DTC P2185, your repair is concluded. Otherwise, repair any open circuit in the TW2 sensor wire connecting the PCM and the ECT sensor. After conducting thorough repairs and troubleshooting for DTC P2185, the final step is to verify that the problem has been resolved. First, clear any DTCs that were logged in the diagnostic system. Following this, complete a test drive of the vehicle under conditions similar to when the DTC first appeared. Monitor the vehicle's performance closely, checking to see if the check engine light remains off and that engine performance is normalized. This stage is crucial because it ensures that your troubleshooting efforts have been successful and that the ECT sensor and associated circuits are working as intended. If issues re-emerge, further investigation may be needed to tackle the underlying problem. To prevent the recurrence of DTC P2185, engaging in regular preventive maintenance is essential. One of the simplest yet impactful actions is to inspect all electrical connections regularly, especially for the ECT sensor and PCM. Corrosion or loose connections can lead to faulty readings that result in high voltage errors. Additionally, ensure that the integrity of the wiring is intact, checking for any physical damage, fraying, or wear can save a great deal of trouble. Updating the PCM software to the latest version whenever updates are released can also prevent compatibility issues between components, which can lead to DTCs. A vehicle that is well maintained not only performs better, but also extends its lifespan. In conclusion, understanding and addressing DTC P2185 is critical for maintaining your Honda HR-V's performance. This diagnostic trouble code relates to the ECT sensor 2 and indicates a high voltage condition that can lead to various engine performance issues. Following the outlined troubleshooting steps ensures that you can accurately diagnose the problem, whether it's a faulty sensor, poor connections, or issues within the wiring. Preventive maintenance plays a significant role in avoiding such DTCs, emphasizing the importance of regular checks and updates. By being proactive and vigilant, you can undoubtedly enhance vehicle reliability and performance. Please like and subscribe to the channel. See you next time.